Hello everyone. And this is a solution for the analysis of determinate structure, specifically frame structure. How is determinate? Just before going to that, at first let's see what is its loading conditions and what's this all about. At A, it is a hinge support, so there are two reactions. At B, this is a roller support, there's one reaction. At C, it's a roller support, so there's another reactions. So in total, there are 4 unknown reactions. However, at point D, there is the internal hinge available, provided. That will make this structure a statically determinate one. Okay. So due to the arrangement of this structure, the this DC portion will be on top of the other parts of the frame. That is A, E, F, B, G, D. So this portion will be below of DC. So now let's start from the portion DC. So if we take summation moment at D 0, then we can easily find out the value of VC, and from summation of Fy, we can easily get the value of Vd. Now you can see the Vd is acting upwards, 60 kip. So for DC, Vd is acting upward. But when we consider the other remaining part, that's Vd will acting downward to that frame. Okay. Now, so from if we take moment at A, we can easily find out the value of reactions at B, and from summation of Fy, summation of Fx, we get the other reactions as well. So these are the all reactions. So H is equals to 120 kip, BA equals to 6 kip, and VB equals to 26 kip. Now we have to draw shear force and bending moment diagram. Okay. Let's see. Let's talk about the vertical member. That means the column first. The column has uniformly varying load. Okay. So uniformly varying load. Before going to that, I just would like to emphasize on how we get the VV equals to D. Look, if we take moments at A, this 120 will give positive negative. If we take anti-clockwise moment as a -1, so this will be a negative moment. (120 times 16 will get -1). VV times 40 is a +1. 80, this is also -1. So all sum up, we get VV equals to 266 kip. Now this uniformly varying load, the reaction is acting towards left. So the shear force is acting left by here. Then it will gradually, it will decline. At the beginning, it will decline rapidly, and after some time, it will be like this. So this is the shear force diagram. And for the bending moment diagram, there is no moment at this point, and the moment will gradually increase like this. And this value, how do you get this value? If you look at the column, at just the bottom part, it's HA. HA will give the moment, and this load will give another moment. So considering that, this is 120 times 24 minus 120 times 6 equals 960 kip. And this is the resulting moment will acting like this. So that's why this is 960 kip feet. Now, how can we draw the bending moment of the full frame? At first, let's draw the top, the beam part. Okay. So this is what's the shear force diagram look like for the column, from the column. And here, this is vertically going downwards. You see that? Vertically going downwards. So we can say this is taking like this. So 6 keep going downward, 6 keep. And there is no change. No change. Here, 120 keep going downward. So it's total 120. So 120 going downward. So it's 126. There's no change. At this point, at what's that? At a B point, reaction is 266. That means it's 126. So it will going upward. So it will, so 126, so 140. So in total it's 266. So 140. Another, there is no change. 80 to now it's 80 downward. So at this point it's 60. There's no change. And it's like this. So the maximum moment will act at 10 feet from the right support, or zero shear is at 10 feet from the right support. Now we have to determine what are the values of moments. Previously we got, this is what we got from column. So we got column anti-clockwise moment 960 kip. So for the beam it will be clockwise 960 kip. So that's why this is like this. And from here it will, so from here we can say 960 minus 6 times 16. So the value is 864. At B point, 864 minus 126 times 24. 864 times 126 times 24. So this is 2160. It's a negative moment. At G, so this is the positive. So 140 times 12. So 2160 plus 140 times 12. So it's a 480. It's still negative. Negative. And at D, this moment is 0. Because why it's moment 0? Because it's an internal hinge. And also from the calculation, we also find that this is 0. MH, that this very location, the moment is 0 plus half into 10 to 16, so 300, and C will be 0 again. So that's how this is the bending moment diagram of the structure of the frame.